Okay. All right. Okay. Yeah. For the approval, the TA will do that first. So let's talk before we begin the lectures. I know that it will be a bit hard for the class on Monday, especially 8:30. So I don't know what to do. I actually at first I thought that maybe we can start at 9:30 instead. Of, never mind. I think 8:30 is great, and should give us lots of time to cover content in the topics. Right. So let me first introduce myself. This probably be the first class that we see each other. Right. My name is Santitam Prom-on. I teach at CP for 12 years. 15 years, I guess. 12 to 15. I don't remember. Quite a long time ago. And I also an alumnus from CP as well. Back in 2002 to 2007, 2002 for the bachelor degree, and 2009 for the PhD. So I have been working on lots of research projects related to data science, related to machine learning, modeling, using computer, incorporating with biology, with pharmacology, with business nowadays. So yeah, I really love to share those experiences with you guys here, and we'll talk about them. And I would love to answer the questions that you have. If you have questions related to data, any type of data, whether it would be like the data in the normal sense that you have customer data, or data in time series, in like connected network, right? Network type data, and also other types. Like we look at those here in this class. Like the name suggested, is data models. What we are going to learn here would be modeling data and how to create visualization, meaningful visualization for your data. And that's it. All right, and many of you might have known me by the nickname Ajahn Yai. Not really the corpse, the actual live human being here. So that's about me, right? And we have our two TA here. Maybe you can introduce yourself a bit to the class. Min, maybe we can start with you.
Hi everyone, my name is Pathalapon Hanasiyan. You can call me. I am one of TA of this class.
I'm Suthavi Virapong. You can call me Lake. I am your TA of this class. And I have you be TA before this class too, in algorithm design.
Crap, great, nice. So you can ask both of them if you have questions related to the class. They have already learned it with me in this class in the undergrad. This class we use R, right, as the programming languages. So if you have written C and Java, whatever, or Python before, this will be, I think this will be easy, right? R is like quite interactive language that allow you to purposefully modify the data and create a model out of that. It is comparable to Python, right? If you can use Python, if you are familiar with Python, then R will be very similar to that. Okay, right. And yeah, I don't want to if it's like it will be a little bit hard to introduce everyone, right? So maybe let me get started. Do you have any questions before we begin here? If you have questions related to the content, to the lectures, you can raise your hand using reaction. You raise your hand, and then open the mic to speak. I'm fine with that. Or if I forgot something and made a mistake during lectures, that happens. Yeah, humans make mistake. You just turn on the mic and talk to me, right? And another channel for you to ask me the questions is the chat. If you have questions, put them into the chat. I usually check them regularly during the talk. Somehow lectures now become like streaming, like I'm providing some streaming service. Sometime maybe I will play games and yeah, let's stream the games and then teach later. Okay. Right. So let's begin. Okay, let me share the slide here. Right. The name of the course is Data Models. Right. This course was proposed by me, I think, 8 years ago. 6 years. Yeah, I don't remember. When we revised the curriculum. Right. I think at that time I think that it would be great if computer engineer would also have ability to create models, right? Rather than focusing on just programming algorithm, you should focus on the representations of phenomenon that you want to study, that you want to work with as well. And in order to capture the information, in order to capture the variation in the actual process and play with them and understand them, you would need some types of medium, and that type of medium is data. You might have heard a lot about the catchphrase that many people talk about, like AI, artificial intelligence. We have data science, data engineer. We have data analytics, or something like data platform. You have different process try to do the digital transformation, changing from the normal human interaction into something like the system that have IT system to support that, and with that it allows us to capture what happens. For example, right, we have if we talk about traditional finance, right? We have like a way that you go to the market and then pay with money. Now, when we have bank account, and you can pay with bank account with credit card, and the money in your account will be deducted, right? And that's some people call that a client server model. Right? You can deduct it out. Nowadays there is like peer-to-peer way that you can also process that, right? And data would be stored on some types of medium. Now will be the distributed manner. So you can see that there are evolution of business, of the process, right? From the normal transactional base, account base, to peer-to-peer base, and the data as well, it would evolve with that. Okay, so you can see that data are in every process, right? Even when you are studying here, your data have been collected. I am also storing this data, this session, onto the disk so that you can view it later, right? That's one of the things. If I'm really strict, I might have some types of polling to asking whether you are coming to the class. Then I will have another set of data on attendance. Or maybe we have quizzes. Then you have to do the quizzes, and I have those answer as data as well. Right? Even when you wake up and you turn on your mobile phone and open some app, the data of those apps has already been collected to the server. And with those data is like sometimes it really represent yourself, right? Represent your personality, represent lots of things. And that is what we are going to try to understand. Get a glimpse of what really happens through the process of modeling and creating graph, creating visualization that can explain those behavior. Models and visualizations can be biased. It can be truthful, right? After this class, I wish that you would be able to discern those aspects as well. Let's get into it, right? Right. So the learning objective of this course is that after this course, you should be able to apply suitable model. You should be able to analyze the question and then apply the suitable technique, suitable data modeling technique to address that question. Because that means there will be plenty of tools, right? Plenty of technique that you have to choose from. Pick one that is suitable for the problem. Then it will give you suitable answers. Pick another one that is not suitable to the problem. It will also give you the answer, but that answer might not be that accurate, right? So the choice is important. Okay. The second learning objective is that you should be able to create meaningful visualization. I would like to emphasize the word meaningful, right? Not beautiful. Meaningful visualization, right? That allow you to address certain thing that you want to convey, the information that you want to convey. For it to be beautiful, I leave that to your artistic sense, right? Some you might make the graph look nice. Well, not me. But you can also, but for this class, you need to be able to make the graph, the chart, to be informative and to be effective in order to communicate that to your stakeholders. Can be your friends, can be your later on it might be your investors. Right? That is important as well. Okay, and the last learning objective is that you should understand the concept of data science and how to conduct a data science study. Right? This course, at first, I like to name it like data science course, basic data science course, but still like a lot of things. So let's focus on modeling and visualization. Okay, the book that we use as the reference textbook, I call it a reference textbook because I am not going to follow the chapter like chapter by chapter on the book. You can use this book to learn R for data science, right? But the lecture that I have, I build it up here. They are mostly from a lot of revision that I created my own part of that. And another part is that I also use some types of, also reference to the textbook. A lot of textbook like combining together to be this lecture, and I used it to teach the data science course both in our university here and also when I conducted a training for industry. In the past 2 or 3 years, I taught actually I would say in the past 7 years, I taught a lot of courses for industry, the software industry, both like telecom company, banking, insurance, right? They like to learn data science as well, and these are like the resulting materials that I kind of revising from comments and then creating them up, right? Hopefully it will be beneficial to you, and it would be nice if you have questions about them. I would like that. I would love that you have questions, and so that we can make this course more like discussion rather than like me giving lectures and you just listen to the talk. So that means interact with me a lot, so that I will not be lonely talking here. It would be nice if we have like go learn at the university. Hopefully, for you guys, COVID generation. Should have an opportunity soon to learn at the university. It's nice, I think, but there are downside and there are good side about learning on site and learning online. Like learning online, you all see what I presented here, and there is recording that you can view later. Learning on site, well, it depends whether you are sitting in the front or sitting in the back sometimes, and there are no recording. except if I were to bring my camera here with me to the class, but that would be a little bit troublesome. What else? Yeah, that's beside the topic. Oh, by the way, I will share the slide here before the class, right? For every time that and we have the class, I will try to post it as soon as possible, so that you can, if you want to review the content first, that you can do it. Okay, now let's get to the topics here. Let's talk about grading. Okay, we have questions. Good. Your friends ask if I can post the lecture. There's no lectures in LAB2. Sure, I will post that into the Facebook group that we just created. I think that will be lecture 1, Introduction to Data Modeling and Visualization. Let me add the file to the group. It's going. Okay, the lecture 1 is uploaded. Okay, you can review that later on. Otherwise, for this class, you can just look at the screen. Okay, this class is still introductory class, introductory lecture. This lecture is still introductory lecture. That means there aren't any coding yet, but later on you will have to do that during the class as well. So you need to install R Studio, but I will talk about that later. Never mind. Okay, let's talk about the grading first. Grading here, because this term is a little bit strange. The university decided to have the term separated into 3 parts rather than 2. I don't know. I don't think they really understand that having examination is quite stressing. so they said maybe you can have a 3 break and have the exam 3 times, and that will be less stressful. Okay. So it is, but we have here. At first, I prepared it as usual, but never mind. Let's use it like this. We'll have 3 examinations, right? There's the first, second, and the final exam, right? Each of these would worth 20 points in terms of score. You will see the topics later on. I planned the date already. And then for this class, for each of the lecture, you have to submit the lab. There will be lab for each lecture that asking you to do certain analysis, like, okay, use this data and doing this analysis, and then submit the work to LEB2, for example. And there is also a term project, which I will post the syllabus so that you can look at the explanation of the term project. Basically, you need to form a group, form a team, and then choose a data source that you want to study, and then performing exploratory data analysis, creating visualization from that source, and afterward doing the modeling analysis, so that you can analyze whether the trends for doing prediction, evaluating the model, and then report the result. Okay, so that is for the term project. Yeah, so this is a score distribution. Okay, do you have any question about this first? And otherwise we will move on to the next one, which will be the schedule. It's kind of uniformly spread. So yeah, let's look at the content, the topics that we will cover in this class. As you can see here, I already planned the day and the content on of each topics here. We'll first start with the first four lectures. Today's lectures about introduction to modeling and visualization, and the next 3 weeks will be R programming. You learn how to write programs in R. Then how the basic type of data visualization, right? Which visualization are suitable for which type of data, or which type of information that you want to use. Like which chart is good for numerical data, for categorical data, for comparison, for seeing the trend. You will see those in the third time, right? And the fourth time, you will first learn about distribution. Right? We're now incorporating statistical analysis, right, into our class here, and then use those techniques to create visualization that allow us to understand data, especially in terms of distributions. This topic is really important. Like even now, I have been working with a lot of companies like AAS, KBank, SCB, lots of bank, insurance. I can tell you that in those projects, in every project, you have to use the concept of data distributions. And that is what we are going to look at here in the fourth lecture. Okay, and afterward, first evaluation, right? First exam on the Valentine Day. Yeah. Hopefully that will be a way to show you my love. Yeah, first evaluation. Then the 5th, 6th, 7th, and 8th lectures will be about relationship, right? And this is, yeah, it's kind of in the previous years, the topic of relationship always comes up on the Valentine's week, and it's fun to kind of make a gimmick and a pun on that, but never mind. This year we're on 21st. Relationship, we talk about when you have like multiple variables and you want to find association between them. What cause certain things? So we would try to answer those. What are the factors that allow you to predict things that maybe you might find it useful? I built a lot of predictive models that like customers, companies want to know if they want to identify customers that are likely to make a purchase, how they do that. Are there any sign? Are there any signal that will allow them to perform prediction? And that is what we are going to look at on the 5th lecture. And the 6th lecture will be about networking. Last week on Friday, I just taught in provided a lecture for Bank of Thailand regarding the usage of network data. For example, with the network data, you can identify the cryptocurrency wallet, whether which one are potentially be the one that are belonging to the same person. Right? So that you can trace the network in that sense. That's one application. Another that I consulted the it's like Metropolitan Electricity Authority, right? The MEA that govern electricity provider in around Bangkok area, about how to use network analysis to identify the point that they should build or they should relocate the service center into that region so that they can tackle problems around the area efficiently. Okay, so those are potential applications of network. Or you can think about social network or creating a games, right? Which games are you playing right now? So I teach this course like so many years. The games has evolved from back then. There are something like people playing ROV, Overwatch, Free Fire, to now what Genshin, So what are in trends like right now? haven't played lots of games lately. Yeah, give me some example that so that I can use. What are the games that are in trend? Don't tell me that you don't play games. Valorant, FPS, Valorant, okay. What else? Come on. Are we still in trend? Is Hearthstone in trend? Genshin is my life. You are saying that the not loot box, right, is now like, yeah, the loot box is your life. The salty one. Minecraft? Tetris? Cookie Run is quite old. Well, Minecraft is classic though. My son start playing that as well. Starting to teach him how to write a code on Minecraft there. Slither. Minesweeper is too old, even for me. Minecraft 2, that's long time ago. I finished that long time ago. Roblox, yeah, Roblox is nice. Yeah. Inscription is some times ago as well. Seems like you don't have lots of time to play games. Or am I wrong? Never mind. Okay, for example, say Ragnarok Online. Let's use ROV as an example then. It's like a mobile game, right? So it means that you have to battle with another team. Okay, and each time that you are battling with another team, it means that you have like 5 people battling with. Is it 5? I don't remember. For whatever. So you have like the team clashing up with another team, and that means there is certain interaction between the two teams, between individuals, right? You have, and that create association between the unit, and you can build a network, right, representing those units to perform analysis like the teaming up, which teaming up often occur, right? On a network can be used to do something like predicting whether people have certain relationship with one another or not, like in social network, right? How does Facebook know that you should be friend with some people, right? Or what types of content that you would like to see? There have to be a way to extract that information from the network of friendships, network of friend adding to that network there. Okay, and that's what we are going to look at, how to create visualization based on that, perform basic analysis of distribution with the network data. And then on the 7th and 8th lectures, these will be about modeling, right? We are now creating a model, the probability distribution model, right? Trying to study that and then simulating that through Monte-Carlo simulation. And that these 4 will form like another model that will have the second evaluation afterward. And you can see that I can put the topic up here because there's like 1 slot available here, but I think we should leave with 4 and 4. Otherwise it might be like too much for you. And here is the second evaluation. We will see whether we should have second evaluation around this time, and then there will be like 2 weeks break for Songkran festival. Hopefully it will be normal afterward. Okay, and during this you have to submit the proposal, right? You have to submit the proposal for the project. And after the breaks, then we'll come back to learn a little bit more about machine learning model. Right? It's still on modeling, but now it will be the machine learning model For this class, we will cover like three of them, right? Three of the machine learning technique: linear regression, logistic regression, and decision tree. Right? Although there are like a lot more techniques that are quite powerful, like random forest, gradient boosting, neural network. We will not cover that here because we don't have enough time. That's one of the things. Another thing is that I think those topics, if you want to study them fully, will be suitable for the full machine learning class, and not just like half of that, or 1/3 of the class here. But in any case, since these are also types of model, we will learn that here, and also how to evaluate that, and finally in temperature presentation. Right. So this will be the topics of our class. Any question that you would like to ask here first? Yeah, for what I'm doing now is that I'm opening YouTube to show you the last year playlist if you want to look at that.
อาจารย์กับI can see Facebook group request of them in Facebook. I think I doesn't have a permission.
Oh, really? You don't have permission to let them in? I thought I already allowed that. Let me check. Approve all then. Okay, you are all in. Actually, there should be automatic member approval, which I should set the criteria that you should be friend with someone that is already in the group. Yeah, confirm. Now your friends can add yourself into the group, I think. Come on. Confirm. How come the automatic things doesn't work yet? Yeah, man. I'm going to set the criteria to be you should be able to add yourself in as long as you are friends with somebody that are in the groups. If not, then just add yourself in. Then if I see that, and I'll add you to the group. Okay. Thank you for notifying me. Right. Any question about this? About the topics? And we use R to do all these tasks. And from this course, if you want to study further, you can go into different paths, right? You can go to on one part, you can go into the data visualization part, which will lead you to different tools. Like if you want to create a web-based visualization, and there are tools like Wiz.js, D3.js. If you want to do this type of data visualization in another language, you can do it with Python. If you want to do it with the visualization tools like Power BI and Tableau, then that's the way as well. That's one part that you can go from this course. Another part is that you can dig deep into the statistical modeling. Right? That I already covered them like 2 lectures here: the statistical distribution and Monte Carlo. But there's actually the whole set of topics about data simulation, about creating a simulation models. Creating a simulation model is basically building a games. You can learn game theory in order to perform simulation for the game theory. and that would and you can create a mathematical model and then simulate them to perform projection. You might have seen that in the news there are like projection of COVID infection rate, right? That they are expected the curve to be like a certain shape. That comes from simulation of the model. Okay. And you can also pursue the path of machine learning, which allow you to create a model that learn from data, not just from like a basic mathematical construct. But you can have that set of data and then let the model learn by itself. It's cool. It has certain limitations, but combining all of these would allow you to like tackle data-oriented problems in different aspects, like on the aspects of your own assumptions, creating simulation model, on the aspects of just trying to understand them, creating visualization, or on the aspects of let the model figure out relationships between input and output, right? And that would kind of allow you to, I say, answer the questions about data in the basic step here. Okay, for the term project, okay, you have to form a team of 5, and then there are like 2 main tasks: visualization and modeling. For the visualization, you need to create visualizations based on a set of questions that you raised from the data set. And for modeling, you need to first identify what types of modeling objective your project will be, and then build a model, perform prediction, perform evaluation. That's it. And then what you need to submit is a technical report at the end of the terms. And you need to present the work to the class as well on the 16th of May. Okay, I already put that date onto the calendar here. Right? And this is the whole thing about the introduction to the course itself. In the latter section, we will cover the introductory to data modeling and visualization. I will give you certain overview on what types of application you can do after this course. And before we go to that, do you have any questions about the kind of plans that we will use in this course first, like the schedule, model, the projects? You have questions, put them in here in the chat, or turn on the microphone and talk to me here. Any question? Okay, if still no question, I think we should begin. It shouldn't take long for the first lecture. We might finish it like about 10 or 10:30, probably around that time. It would be great if like you have not just reviewing this, but think about it as well. Taking note is not as important as interaction, right? Because you will have recording anyway. And the thing that I'm going to show you, and before that, I have this. Let me share this. Okay, everything should look okay. Here, this is the recording of last year lecture. It contains, I think, almost all of the lecture up to linear regression, right? Not completed though. I will try to make the new one for this year that is more complete. But in case that you want to see what you learn in others, you can look at this. It will cover that up to linear regression. Yeah. Although some of the lecture are not here because I think I post because I think I don't have enough time to edit the video, and I post the video directly, the Zoom video directly to the group, so that there's no like YouTube recording if in that sense. Okay. So shall we begin? Let's look at the what questions and why would learning this course will be beneficial to you in your further study in computer engineering in the or in, like I would say, in business that transform itself from traditional type to digital oriented type. Okay, what are data visualization? What are modeling? Just imagine that in the certain process, when the company want to acquire customers, right? The prospective customer might when you see some products that you are interested in, right? One of the way that you can know information about those products might be to call the call center and talk to them, and by calling the call center and then ask the question about the products, there are already data that are collected from this process. Can you tell me? You can type in the chat what types of data that are collected from this simple process of calling call center. What types of data can be gathered? Phone number. Yeah, the company can get your phone number. What else? Just think about last time you called some type of call center. What information that you gave them? The name, yeah. Some, I would say not all kinds, some personal information that you probably gave them. Especially if you are already customers of that service. They might ask some types of verification, right? What else? Home address? Sometime maybe, but might not. Sometime you might not give them that. They might already have that date of birth. If anyone calling you, let me emphasize it. If anyone call you and ask you from home address, date of birth, whatever personal information, don't give them. Okay? Do not give your information over the phone, right? So, because there are lots of scammers right nowadays. So I would say that thing that you are talking about here, well, these are not the things that are collected actually when you call the call centers, right? What do you think are there is a call center systems. When you call the call center, this system must record something. What are they? Okay, I can give you sometimes voice call, correct? The whole conversation, and also the operator at the call center also typing and inputting data that he or she perceive to the system. So that means maybe your gender or the types of question that you ask would already be recorded. The timestamp that you call in. And if you are already customer of that system, they will know all the type of thing that you mentioned without you having to give them any information. But they will know that, okay, you are calling at this time for this problem, and what are the details about yourself. Okay, so these are the information that will be collected. Right? The question that you ask or what operators type in or put into your system. Now let's say that you are okay. You are now become more interested to with the service. Then you log in into the website, and then view the website. When you're viewing the website, actually, the data have already been collected. Now, can you give me some examples again? What types of data that are being collected through this process? IP address at the technical level. Yes, what else? Because you are browsing the web, clicking the link. The item you are interested in, not bought yet, but maybe just viewing the page and it already load up, and that is already the data might be collected from that step in order to optimize the advertisement when you want to view them. Okay, then you have items you want, then you add them to the cart. Obviously, you have already make the choice that these are items that you want and add them to the cart. Adding to the cart means that you already have made certain actions, right? You have already made certain actions to say that, okay, these are the things that you want. So those are the data already. Okay, there's a question here. The item you were speaking about, and there's ad everywhere. Yeah, true. How many times you click on the item? Yes. And this data sometimes is called the click stream, right? The click stream, because they are recording the click that you interact with the website, and then use those data to find which part of the website that people likely to click, and which menu are the favorite, which one is not, and even what types of advertisement would attract more audience than the other. Okay, then you make a purchase, paying would be recorded on the database. Then you become an enrolled customers that use that service. Then you always kind of contribute the data to the systems. And this is like the transition from the prospective customers, the one that are not in the system, to the one in the system. You can see that even just the onboarding process already have lots of steps to collect the data. Okay, and for these types of scenario, that when we talk about the customer passing through the process and then use the service, is often referred to as customer journey. Okay, the customer journey is a step that customer take when he or she interact, he or she use the service. For example, if I want to create a systems to provide service to students at the university, what I need to do is that I need to first study the student journey, from admission, from registration, and through the process of learning, and at the end receiving the grades, and then we can graduate out of the university. But I have to study the whole process and draw this up to know that on which part that the data should be collected, right? On which part that there's an opportunity to collect the data, and then and what types of analysis that can be done from those data. Okay, so this is like customer journey, right? The customer journey data can be basically divided into types, right? These are the types of customer journey data, or you can replace customer with something else. Like I can have like student journeys, or a machine journey, or a network packet journey, right? So it depends on what you want to study. We have in the middle the unit of analysis that you want to study. This unit of analysis is often referred to as the unit on which you want to study, and sometimes it relates to customers. But for example, if I were to study not in terms of customer, but my project is about predictive maintenance, and I want to study how what are the factors related to the problems in the machine. Then the middle here will not be customer, will not be human, but it will be the machine. Right? The machine may be the computer, the cars, whatever what the thing that I want to study. Okay, and that in terms of data, that will be the goal. That will be that will be the role in your data set. That when you prepare the data, finally your data should be in forms of table. You learn database together in this semester as well, right? In the database course, you learn about the tabular data. Okay, so you need and you learn how to write SQL to extract data, whatever in that course. But when you perform a study in the data model in data science, you need to summarize the data, prepare the data, so that each row in the data set that you prepare had associated with the unit of analysis. Okay, and for this we can have something like if we talk about customer journey, then each row would be each customer, and then each columns will be like variables related to customers. What are those variables, right? And those variables can be divided. Those variables sometimes refers to as attributes, can be divided into basically 4 types. The first type, the easiest one, is demographic data. Demographic data are the data that represent unit of analysis in one-to-one manner. It usually describe the demographics, a simple explanation, or the thing that explain the unit of analysis in one way, like age, gender. Right? So you have like one value associating with the unit of analysis here. Or for you guys, might be the department, right? The department that you are registered to. Transaction data. The transactions data are the data that relate to business operation. For example, if we talk about university, transaction data can be the the subject registration, because each student has to register to has to enroll into each course, right? So those are transactional. Transactional data can be referred to something like transferring money from one account to another account. That's transaction data as well. Or the purchase data. Interaction data. These data comes from the interaction between the unit of analysis and another entities. These can be something that are related to business. For example, if the customer call or email the company, then that provides intentions more than just using the service. Okay, interaction data can come from call center note, come from dialogue, and and sometimes interaction data can comes from the interaction between unit of analysis themselves as well. Like the earlier example that I used about the ROV, about games. Right? That one team had to fight with another team. They need to have interaction, right? Fight together. That's one game. Now another game, you might be matched with another team, another set of people. And then that create a type of graph and a type of network, a type of interactions. And yeah, that is all. Those are the data in the interaction part. Think about it as peer-to-peer data. This is like client server data, like customer with business. This is like customer with customer. Like when you chat with your friends through Facebook, you create interaction data with your friends. And that can be drawn as a network to study. And lastly, this type is like the most desirable types of dataset that business want, because if they understand this about you, they can provide service to you. They can sell things to you or offer service, increasing revenue. If they understand that about themselves, they can reduce the cost. They can do many things, like depending on the questions. right? For example, understanding the need. For example, at the end of the years, right, when you have to pay tax, right, for the earning by the end of the years. And by the end of the years, there will be a lot of service, a lot of, like I would say, the investment company that try to approach you to make a purchase on certain types of investment, like the SSF or RMF. But for the bank to know that you need them, they need to be able to analyze your patterns, and they know that, all right, throughout the years, you use this bank account as the like salary account, but you have not purchased any types of fund. Then they might use that to list you as the top candidates for their product, for example. So this is like analyzing the need. Or the food delivery company might analyze whether you want to make a purchase on this time or not. This is the hungry time for you or not, right? So this is a need, the desire, the types of things that you want, and preference and opinion, and can come from like interaction data, transaction data, and then you creating metrics to measure those opinion out. You may have heard this from the news that like in 2018, Donald Trump, right, used collaborate with the Cambridge Analytica, the company that analyzed data from Facebook to analyze opinions of people in United States, that on which part, on which towns, what types of topics that are important, and then they use that to shape the message and to attack their opponents there. So that is the use of I would say the scary things about understanding opinions there. Okay, so here these are the different types of data, and I hope that when from now on, if you see the thing that can be collected, you can classify them whether they are demographics, transaction, interaction, or whatever. Let's look at some example. These are example of demographic data. Demographic data explain individuals like age, gender, income, occupations. You can see that these are usually associated with individual here one by one, or sometimes just a few set to one, right? Handset, geographic location, and property values. These are demographic data. They are quite static. That means they are rarely changed. They might be changed, but rarely changed. So, for example, your status as a student is demographic data. It's not permanent, but it will be like this for at least 4 years, right? So that's demographic data for you. The transactional data are the data that unit of analysis interact with business, like call detail record. When you call your phone, this call record will be recorded by the telecom company, so that the regulator can. Regulator has the laws that asks telecom company to collect like 10 years of this CDR, this call detail record. Internet usage, when you use the internet, it will also be recorded usually, but not analyzed. Recorded as the law stated. Location of the tower, CRM data, service plan, payment information, app usage. These are like the thing that occur when the business runs. Or transactional data for like food delivery app can be the data of order, the order data that when customer made an order. That's transactional data. When the food is being fulfilled, right, from the shop to a customer, right? That is also transactional data. Interaction data are data that occur from not the core business, but something like an intention to communicate. That's one part of it. Another part is the one the data that can be drawn as the thing that comes from interactions, come from individuals interacting with another individuals. Like when you send email to your friends, right? We will have if you use the like company email, the company can use a way can analyze the email communication. Why would they want to do that? They might want to do an audit to audit that there is no breach of data security in the company. And they need to analyze the whole email structure in terms of communication, whether there is like a file attaching sending out of the company and how many times that happens and what types of data that is. Then they can make conclusion in terms of like the IT audit, whether there is like a security breach, data breach or not. So those are interaction data. Behavioral data like the like metrics in Facebook, collaborative filtering that has been used by Netflix, by YouTube to select content to show to you, or when you add things to wish list and you are browsing through it, those are the behavioral data. The need, like the laws say that you have to pay tax at this time, they will create a need, and if the company can utilize those, they can make use of this data to perform the action that they want. Right. So now you see different types of data set. Now, what I would like you to think about and then tell me on the chat right now is I want you to think about student journey. Think about your data in the university. And then pick one example and then tell me whether they are demographics, transactional, interaction, or behavior. Okay, go ahead. Put them into the chat. Just one example. I give you 2 minutes to think about that. But if you already know, just type away. Grades, demographic. No, the grades are transactional. Why? Because grade occur from when you enroll to the course. That means every time you enroll to the course, you can get the grades, right? So one person can have many grades on each subjects. But if you talk about the GPA, that can be the demographics. Okay. Student ID demographic, okay. Yeah, it's the ID data. Chatting with TA interaction, that's true. Okay. What else? I need at least 10 to go on. I need to recharge a bit. I need at least 10 answers to recharge. Joining event interaction, okay. Yeah. Parent income demographic, okay. Yes, 5 was already. I need another 5 to move on. Come on. There are like 50 of us. So I just asked for like 20% response rate here. Teacher evaluation, behavior data. I would say the teacher evaluation is also a interaction data, right? Interaction data, because you create a type of bipartite graph. Teacher evaluation, you might evaluate the same teacher more than once on different subjects. So it's a type of interaction data. Okay, 6 already. 4 to go. Think about your think about the university. Think about the process that you have been through so far. What are the data that are collected by the university? There must be some, right? Wi-Fi usage, yeah, transaction, that's okay. Yeah, 7. List of costs each student apply, transaction, true. Yeah, the cost, the registration, enrollment, transaction, major, demographic, true. Okay, that's 9. 1 to go. Yeah, the last one. Going in out university behavior. Going in out university, I would say that's transaction. Class attendance behavior, that's a transaction. That's related to the main business, right? Should be transaction. Shopping online, behavioral data. Shopping online, if you shop online, that will be transactional for the shopping online, but that's not related to university. I know that you shop a lot because of the work from home, but well, not related to that. Okay, thank everyone. Let's move on. Okay, I got lots of slides. Well, I'm going really slow there. Okay, and the data that are collected can be classified. It can be ranged from like outside data, the data outside company, right? Data outside company, and the data that are inside the company. And these data like can be ranged from the social media data, because you can see that the data from the left-hand side are not usually owned by the organization. They are owned by the social media company, not let's say university, not in the telecom company. The ads also owned by the data located at the ad company, not the company that might want to use them. Right, so you have like the data from outside and the data from the inside that you can collect, like the CRM data, the transaction data, call center data. These are the data that usually are stored inside the company. It's like there are systems that relate to these types of storage. What I want to raise here is that there are with different level of being like whether the data is outside or inside. It will make the question that the data can answer be different. This is the thing that is, I would say that a lot of politicians, when they talk about data, these are the things that they are not aware. That sometimes they say that, okay, you can study social network and then you know which citizen want to do which. Maybe you can't, because there are because you cannot pinpoint whether this account belonging to whom. So there are certain limitations in terms of question that you can ask and then can answer with certain type of data. For example, the outside data, then you can ask maybe general question like what are the key segment, what are the keywords related to certain segments of customers, like related to young adult, like 18 to 20, less than 20, studying university. What are the keywords that would give them inspiration, that would tick them, that they don't like. So this will be the thing that you can study from the data from outside. But now transition to the inside, you can answer the question that become more specific, like what are the features that drive adoption of your product? Or from the inside data, you can ask something like what are the behavior of your customer that would trigger churn, that would trigger customer to leave the company? What would be the features that the customer like? Right? So these are the things that can be answered by the data from the inside the company. But there are certain things like that need data from outside. Okay. So hope you see this, and it's not data analytics and data oriented approach is not an or be all approach. It's an approach, I would say, that open your eyes, open the eyes of the company, open the eyes of the organization to see what they have and to see the path forward. Right? So that's data for you. It's not like do anything, make things success at the end. It's like the thing that allow people to see, allow the allow the company to go into the direction that they consider. But there's the ethical thing here I need to mention. Is having data doesn't mean that the data has to be right. You know that there are fake news, right? There are fake data. It can occur. Fake data can come from partial truth. Right? There can be partial truth, or there can be some aspects of data that can be interpreted either way. Or there can be a data that is just one incident, but has been generalized to explain more than it is. Right? These things called fallacies, and it's not just occur in arguments. It's not just occurring in the argument in the normal statement, but it also occurs in the data world. That you can have some people intentionally misinterpret data in order to make things be on their favor, or in order to attack their competitors. This occurs in business, and it is in life, not just in this era, since back then. Okay, so yeah, there are certain ethics in data usage and in being data scientists, that you have to adhere to the scientific exploration, question the data, and then think about it carefully. Okay, now let's think about the data again. The data have difference. This is the old stat. New stat has a lot more than this, but what I want to show you here, that the transition from different types of IT, from the mainframe to client server to the internet to right now the social network, has created a new type of IT. Right? We now have cloud computing and on-premise. We now have like peer-to-peer distributed computing that now becomes things that are has been discussed in the field. And also it create like the rise of data from just the data occurring in the server, occurring from just interaction of users, to something like the data that occur in one-to-many and many-to-many styles. Right? So and in terms of technology right now, a lot of data are created and are stored by these companies. Right? Although I write it like this, doesn't mean that some company will have a really limited data, but some company really have like a large storage of data that need to take care of and then make use. For example, banks, the large banks has a lot of data traffic that they need to create a model, need to have a way to analyze those data quite interactively, so that they can act in time for a certain thing and make use of those data into another thing, right? And that said, that will make this statement becomes true. That this statement has been made for quite a long time. This is like 2006 by Cliff Humby. That he said that the data is the new oil. That the oil in the 19th centuries will be actually the oil in 20th century is the data in the 21st centuries. The data is the new oil in 21st century, because you can see that the top company right now in the world use data to for their main business, and data is an asset that allows some company, even in Thailand, to flourish and then have a lot of valuation. For example, Lazada sold like 1,000, a billion. I don't remember the name. Like 100,000. No, it's like $100 million. I don't remember, but yeah, quite a lot of figure there. But yeah, that means data is something that represent thing that happens, and if you can make use of that, it will allow you to make proper decision related to those process. Okay, that's why data is new oil, but it's like the crude oil. You need to have a way to process the crude oil so that you have the final product that can be sold, that can be used. That means data alone is not enough. You have to have a way that transform data into decisions, into the thing that can be used to make decisions. Okay, this is an example of the way that you can use data to make decisions, right? This is what is called a DIKW pyramid, right? Data, information, knowledge, wisdom, and decision. This pyramid just tell you the data rate, that when you think about data, right, it kind of, when you narrow it down to get only important thing, the data rate will be reduced to just a small amount, but you can make use that in your work. Think about it like this. Suppose that let's talk about the data here as the news, right? If you think about the news, the data, if you crawl the data from website, what are they? If you download the data from website, say pantip.com or Facebook, if you are able to download them onto your computers, what are the data types that you will get from those? Integer, list, string, the data type. String, right? You just get the text, right? What you see on the web is just text and image. So if you were to store them onto a database, then you already have data, right? You can create a system that kind of keep track of the news, store them into the drive. But that's it. It doesn't have anything. This data know nothing. It doesn't have any clues, just some types of data, some type of string that you store there. But it will become more valuable when you give the data first the context. For example, if you were to give a keyword like the names of the company in the in the stock exchange, you were to give the context that, okay, this sequence of letter indicate the thing that you are interested in, then you now have layer of information up here, because from just the text data, now you have maybe the location of the text, the frequency, whether that exists on what time. You have certain relationships, the name of the company, right, and the time. You have certain relationships. Things become more organized, become more structured. And now you can use this to understand, okay, this is a trend. Like Google Trend. Google Trend is the types of this type of information. Give the document a context, and then it will allow you to build information level to see relationship with time, with other things. Okay. But that is this level. If you want to make use of this information, then you need to think, and then make sense of some stuff up, right? Make some plan based on this information. But now suppose that you have also give the meaning into the word as well, not just that this is the token that you are interested in. Let's say if you were to give meaning to profit, mean plus, loss mean minus, disaster mean minus, and success mean plus, for example. Then you now have words that are together with meanings. Okay, and by giving it some types of meaning like that, it allows you to have certain contextual knowledge, have the knowledge level. This knowledge level will allow you to see some types of context that, okay, during this part of the years, there's some bad news coming out. This part of the years, good news coming out, and you see the patterns there, right? It will reveal some patterns out, and then you would be able to understand the data that you have more. Okay, usually the part down here, what I'm talking about here is called the text mining or the data mining, that you try to create a mind of data that you have to see the patterns inside the data. But that what I'm talking about is just a text, but you can do all the time data mining as well. Okay, so now it becomes exciting because we are going to be, I say, a seer to see in the future what will happen. Okay, how would we do that? Right. If we were to give the data an insight on what will happen in the futures, then we will know, we will arrive at the level of wisdom, because we would know, we have an understanding that, okay, suppose we give the stock price to the system, so that we know that next month's stock price will be what values. Okay, how would we know? How would we give the data in the future to the model, to the systems? Can you give me some idea on how do we give the future data to associate with the data in the past? There must be a way. Yeah, we can use it to analyze the trend in stock value, but how? How do we know? How do we give the future data to the past news? Okay, use the metrics to predict future. That's okay, the current metrics and the future data. But my question is, how do we get the future data in order to kind of associating with the metrics that you want to measure? You can see the timeline, right? How do we turn back time or see the future? But we have to get the data in the future first. Now it becomes circular. How can I get the data in the future in the first place? You can do that by using the past data. If we look at the past, for example, I know what types of news coming out in October last year, right? I know what types of news coming out in October last year. And I also know the average stock index value on November. Month 10, I know the news on month 10. I know the stock values on month 11. That means I already know the future in the past. Okay? So that is the insight that I'm talking about. If we were to collect the data back, say 2-3 years, you can kind of sliding the data a bit, so that you have the data maybe 1 month, 3 months in the future to associating with the data from the past. Then building the model from that allow you to make prediction and see what types of indicators, what type of principles that allow you to make prediction. Okay, so this is the level of wisdom. Lastly, if you were to give the purpose or the objective function to the model, say you want the model to optimize the portfolio based on the news to get the highest gain on the next 3 months. If you were to give such a purpose, such a constraint to the model, then the model need to make decision by its own, and that is already at the level of the decision. It need to make decision. So what are an example of this? You might have heard the system like the robot trading, either it's in crypto or in the stock market. The robot trading or algorithmic tradings are the system that would kind of analyze news, analyze sentiment, analyze patterns, and then make adjustment, optimize the portfolio of the investment, so that you get, like, say, the best gain in say the next year, for example, and it will automatically adapt itself. And you can see that with different layer of data, it allows you to create different types of products, from just some type of dashboard, some type of report, up to an AI that can act on its own. Right? So this is the power of data that you can create. And you can classify this type of analysis of data into four types, from descriptive, explaining what happens, diagnostic, to analyze what are the reasons still in the past, to predictive, that you have a model that predicts, say, next month, and lastly to prescriptive, that you're trying to drive things to happen. Example of prescriptive model is like Netflix and YouTube, that it show you content, so that these contents are the contents that are you likely to click. It's come from optimization from based on your preference. Why descriptive analytics is like when you look at dashboard and you see certain information like COVID statistics each day. Right, and on each, it doesn't mean that prescriptive is the best, though. It depends on what types of analytics you need to your task. Descriptive and diagnostic analytics are important as well, because these are the tools that allow you to provide data to human, right? From data with descriptive and diagnostic, you can make human understand and then make decision based on the data. So these two are essentials. Then for predictive analytics, it allow you to kind of help human. Say, I just finished the project that built a predictive model for the bank. So the bank will know who are the kind of prospective customer which will be interested in their loan offer. Okay, so they can make decision to take action to offer the loan to those customers, and it will be better than them doing it randomly or doing it using just the value alone. It would come from the potential of the user as well, and also maybe the risk that user can accept. And lastly, prescriptive system. It can become the decision support system that allow you to help you make decision, or decision automation that make decision automatically. As an example of decision support is the system that help you choose, like when you look at Netflix. When you use, Netflix can be thought of as decision automation because it already made an automatic decision by itself that you want to view this content. Decision support system is like when maybe I think about it like the search engine, I guess. When you have when you have this problem on your computer and it analyzes the error log and it tells that, okay, you need to fix this. Right? This is a support system. You need to make decision afterward whether you want to do that or not. Right? So these different types of analytics allow you to bridge the gap between the data and decision. And among them, I would say, combining all of them here is the concept that you are trying to shape the organization from normal intuitive based decision making into data driven decision making. That is the executive or management in the company. Make decision based on data rather than just their gut feeling. Okay, how would they do that? They need to have a certain system, need to have certain tools. They need to have the data science team that create an automated automated system that help them making decision. Okay, and the technique that allow you to create such a system is data science. Right, and that's what we are going to look at. Data model, data visualization is actually data science. It is a principle, not really new principle. It's a principle that extends from science itself, but you are applying it to business, right, to understand phenomenon occurring in the business. Why data engineering relate to how you can create a system that is more efficient, processing a larger size of data, becoming faster, for example. Big data is part of this. Why a lot of AI is part of the data science. Okay, so you can separate what you study here into two parts. The science part, which we will be focused on this course. We'll focus on extracting knowledge from data, from that represent certain business problems. Why, if you want to study this further in terms of data engineering, you need to study the course like big data, and that allow you to use Hadoop stack in order to like build all parallel programming in order to enhance your computation. Okay, so this is the technology part of the data decision making. And the process of doing the work is very similar to scientific method. Starting from, you need to understand business, understand the thing that you want to study, and then understand the data that are associating with them. After you understanding both, it's like in science, you need to first ask the question, right? But if you want to ask the question, you need to know something about the problems, right? And that is like business understanding. You need to know the problems, and then you need to define the objective of analysis, and then understand data, understand what types of data that you need to use, prepare them, create a model, and evaluate the model whether it is accurate or not. And we will move step by step through this cycle. And after evaluation, if the model is good, you can deploy them into the production environment, production system. Otherwise, then you probably need to revise the model again. And this will be a cycle. This cycle is called Cross-Industry Standard Process for Data Mining, CISP-DM. Is say more or less the standard for data science that we use in the field. Okay, let's take a break first, right? I need 15 minutes break. Now is 10:08. So let's take a break for 12 minutes, and then come back on 10:20. Then I have examples on the technique related to data science, and also some use cases that are out there in the real world that are related to what we are learning here in this course. Okay, let's take a break. During the break, if you have questions, put them into the chat. I will come back and then answer those after the break. Okay. Let's continue. Before we proceed further to the use cases, let's talk. What do you think? Right? What I have been talking about here. You have any question, opinions, whatever? Or maybe if you have things that you like me to teach, you particularly in this course that relate to data model visualization, tell me. Oh yeah, and the use case that I use for the course that I taught Bank of Thailand last week was the Bitcoin transaction, Bitcoin blockchain data. Actually, it's transaction data, the UTXO data. Not necessarily. It's transaction data, like from which account to which account, and then analyze the network there. It'll be fun. You can use that as a project as well if you want to study. Anything you like to discuss before we move on to the next topic? Okay, then no question, or still, if you have any question related to any slide, you can ask me. Some of these will be, I think, some of my slides here will be, I would say that they are beyond your current level. I don't mean in terms of that you will not understand that, but in terms of experience, some of this will be more meaningful later on. If you already work in company, say, and then you have see what happened, really happens on the front line, on the actual systems, then you know that there are certain systems, a certain way that need to be use in order to dig out those data and make sense of them. And I know teaching this to you guys, the sophomore, second year students, is it will allow you to, okay, these are the topics, good, but then what, right? Because you still don't have the problems that you own. Let's try to think about it more, all right? Maybe you can think about whether you can make it into the project for, say, competitions that you want to join, for the startup that you would like to. I would say every startup right now, you need data analytics. You need to create data model, because you need to provide dashboard for customer. You need to provide some type of dashboard for investors. You need to have a way to predict behavior. Even there is that one startup that that built a rice cooker. I think it's called Easy Rice. They built the rice cooker that analyzed the patterns, the behavior of rice cooking, and the setting, so that it will learn, the rice cooker will learn what type of setting that you like, and then adapt it into your preference. Okay, no questions. Let's move on. Maybe seeing examples will give you more idea. I don't expect. You know what? I don't expect you to get everything right now. Right? Some of these require actual go to work, and come back to realize their importance. But at least you should understand techniques. Right? You should understand that, okay, there are these techniques, and then maybe you can use mock-up data, like Kaggle. Right, the Kaggle website, that we'll talk about that later on. Those are the source of projects that you can choose the data from, and then pick out one of that and then do the project with it, and maybe sometimes participating in competitions, earn some money, earn some profile from that. Okay, so with data analytics, with the CRSPDM, you will be able to conduct data science studies. And what types of model that you can create? A machine learning model. Machine learning a machine learning model is a mathematical construct, a code that allow you to learn patterns from data and then make use of them in different tasks. Like in Google search, Google can create a machine learning to learn the preference that you like when you search for some particular queries. Right? It can learn that, okay, usually you choose the data from education institution. Then they can create a preference for you there. That is machine learning, to learn your preference, to learn from the data to get the pattern. Or the Facebook photo tagging, that it can learn the face and then tag the location of the face and the name. Spam, not email spamming, spam detection, learn what type of email what. In game, in chatbot, and recommender, these are the machine learning models that researchers and scientists create to an engineer create this system so that it can be an agent that interact with you, right? And even now with the terms like metaverse, right? People talk about metaverse, talk about that you have like a virtual world, and now I think AI will with that trends. With the trends, I think it's now a hype. More than the trends, it's a hype. People talk about them. Whether it will be real or not, it depends on the future, on the progress of technology. But even with our current capability in interacting with virtual world, like through mobile phone, we can now have interaction with AI, right? Through Siri, through chatbot, through now there are like virtual agent. Or if you look at the games in the Steam, some of the games have a nice interaction that is quite close to human, although interaction way with that still keyboard and mouse though. But yeah, you can see that there's progress in technology there. Okay, that's one type of model, machine learning. Another model that we will look at here will be visualization or visual model. That you can create a visualization to tell story, to tell stories about the data that you have, like this one. You can plot the arrival delay distribution on different part of this United States and then know what are the things that happens. Right? You can create visualization of the count of the weight here and see distributions, or you can create analysis and create a distribution on top of that. This is a correlation plot. It tells you which variable associating with which. Okay. And also you may have seen this every day if you look at the COVID news, that there's like this graph about COVID, and there are different types of studies related to COVID. I would say if you want to know this more, there is actually a very nice example of data visualization. I think it's our world data, our world in data, and then COVID-19. Okay, let me show you this. Yeah, this is our world in data for let me make a copy. Coronavirus. Now, if you are interested in this, you can go to the link here. You can explore global data. This is confirmed COVID-19 deaths. Say you want to know Thailand. Can we look at that? No, you need to add it here. How can I search? It is a little bit difficult here. Here, Thailand. Here is Thailand. In terms of COVID-19 per millions of people, we are on the downtrend since let's zoom in. Let's zoom into since the end of last year's. Okay, we are on the downtrend. This is the confirmed COVID-19 death. Partly because this peak occurred because of Delta, I guess, right? And Omicron still not increase our death rate yet. Hopefully not. Okay, and there are like other visualization that you can view as well. Confirmed death by day, distribution in region, in the accumulation. Okay, using different time interval and different time frame, I guess, to make comparison in bar graph, that you can make a comparison in terms of the change, and also many other things that you can look at here, like the policy, data explorer. You want data set. This is also a nice source if you want to make a study about COVID, but this is in the global sense. For Thai, yeah, I can point you toward like the official data for Thai COVID statistics. Thai COVID daily data is on the open data that you can extract and maybe study that. It will be nice for this class. Okay. All right. Let's continue then. So here you can see that what we are focusing on would be modeling and visualization. Okay, and what types of application that you can do with these skills? You can, for example, you can build an anomaly detection system that monitor the system. Say, create a system to monitor in the manufacturer. They have to produce the product, and during that production, they may have to say control the temperatures to a certain range. Sometimes anomalies can happen, that temperature fluctuate outside the range, and you want a quick reaction, an alert system that would alert the person who are responsible for such a system to take care of the system. That's called an anomaly detection system. After having something like that, the first thing is to identify what is an analytic objective. For this one, I already have that for you. An analytic objective is to monitor manufacturing parameters. and detect whether that event that occur is normal or not normal. Okay, how to do that, right? In order to do that, you need to monitor the data, gather the machine data, analysis using technique and AI data science technique, and then perform action. Okay, so what are the types of data that we have in that, right? The data that we have in the from the machine data would look something like this: that you have different parameters, and these parameters are gathered from different times, and then the idea is to monitor these parameters when according to the time. Okay, the technique that allow you to do something like this is to plot them into something that is called a control chart. This is called a control chart, that it plots the parameters fluctuation and then calculate the mean of the data. And then you have something like this. This is called UCL and LCL, the upper control limit and the lower control limit. This come from 3 standard deviation, right? 3 standard deviation up and down. And why 3 standard deviation? Because from statistics, we know that 99% confidence interval has 3 standard deviation. That means what is 99% confidence interval? You will learn that later on in your statistics. Is it this semester? Your the statistics for engineer. Are you learning it this semester? Yes. Yeah. You will learn about confidence interval. You learn about a lot of concepts, a cool concept that can be applied to this course. You can use that to monitor the data. That okay, this is normal, and this is anomaly, and then make alert from that. You can create an application with this. Actually, there are a number of projects on the 4th years that use this type of model, and then I provide them certain consultants that like, even though they may do the project with other ajahn, they need to create something like this in order to monitor the process. Like there is one project that create a monitor system for companies so that they can monitor servers, that it should act according to the behavior on that time. And then if something happens, then it would alert the admin to take care of that. And these are anomalies, the point that occur outside the range. Okay. And then you can use this type of method to monitor manufacturing parameters, detect something that happens and not normal, and then take care of that. And the outcome of this would be that you have an ability to intervene with problem in time, right? So that's the first example. Any questions you like to ask about that? There are a number. Actually, I implemented this type of system for company outside. I think I implemented this like twice. One time for food manufacturing, the frozen food manufacturing system. I implemented this control system, and another time is for the electricity company, right, to control the level of production. Right. Okay, so that's the first one. The second example is to do the churn prediction. I suppose up until now you have changed the phone provider. You might change from AS to DTAC to DTAC to AS, whatever, switch back and forth. That event is called churn, when you switch from one provider to another, right? For me, I stick with one because I might be too lazy. I don't have enough time to do the all switching stuff. So the company would want to know which of their customer would likely to churn. Why is that? Because they can intervene in the churning. They can prevent the churning. Maybe sometime offering some deal, or maybe sometime just ask them what are the problems. So if they can do that, then they can retain customers that are profitable, and then that will make their business more profitable. Okay, this is called churn prediction. Churn prediction right now is one of the main themes in data science. When you look everywhere, you see subscription service everywhere. Back then, I would say 10 years ago or almost 15 years ago, when you buy thing, you buy thing. When you buy software, you really buy. When you buy software, you really bought the software. and that's it. That's yours for that version. But right now, I think the way to do business changed a lot. Business now changed the strategy from turnkey or buy and sell, and then you own that, into something like subscription based. That is, as long as you are a member, you can update your software indefinitely, as long as you pay the membership. And that comes with something like Netflix, Apple Music, YouTube, Microsoft, 365, Google, and whatever. So you can see that these are subscription service. That means the problem of churn prediction now become the main theme in those, because if customers switch from one operator to another, one provider to another, that means the loss of revenue. Right? So the company would want to predict who will leave the company, who are likely to churn. Okay, how to do that? In order to do that, you need to be able to predict something like this person is going to churn. You need to predict it before the actual event, maybe way before the actual event, maybe 6 months before the actual event. You want to know who are the unhappy one, so that you can take care of that. Because if you wait until the churn date, then it means that it will be costly. Maybe you need to offer half the deal, right? But if the intervention come earlier, then maybe they can offer something that that is not really that costly. For example, they can offer if at here the telecom company might need to offer you like 50% reduction, but here they might offer you something like, okay, there is this mobile phone deal, and if you take that, the company lost less than 50%. They just need to reduce the price of the mobile phone to, say, actual cost, which doesn't cost them anything. Right? So there are certain techniques that to take care of this. But they need to know first who will churn. Okay, need to know which individuals have high probability to churn. How to do that? They already have data. So, for example, they need to have like 3 months data prior to the event, and then maybe 1 month before the event. Here, this is the churn event, and then using this 3-month data to predict the actual churn in 1 month in the future. And then you have the non-churn data and the churn data, and these are different individuals which you can combine them together and then collect the data in forms of a table. Okay, can you tell me that what is the role on each table would need to be in order to do this job? What is the unit of analysis of this problem? I type in the chat. I'll turn on the mic. Yeah, each customer. Yeah, that's easy. Correct. Each customer, right? You need, it will be each customer. That is the unit of analysis. You need the data to represent each customer to understand them. And that data can be like the service months that the customer stay with the company, or maybe the payment in the usage of that customer, or maybe that customer call access the application. Obviously, I use this to teach AIS. That's why it's my SES, sorry. Or the purchase history here. Yeah, I teach it AIS for, let's say, 5 years. In institution since 2015, 2016, 2021. Yeah, around that time, I taught the course in data science for the company, and I'm still the consultant for the data science team there. There are lots of alumni from actually my team that work there, that work there as a scientist and data engineer, and do this job. Okay, so in order to build churn prediction model, you need to kind of gather the data set and then clean the data, pre-process them, build the features, and then choose the model, and then make a prediction, and perform evaluation. And then if it works, then you can deploy the model. right, to the actual system. And then you can use the model to maybe segment the customer into those that are high churn that need to be taken care of immediately. Those that are moderate, medium churn probability, this you can kind of send them SMS or invite them to do some activities to reduce the risk of churn. And normal segment, you can leave them alone. That okay, these are customers that will stay with the company anyway. You probably need to have some way to increase loyalty, but you don't have to use churn treatment with them. The churn treatment should go into like the high churn groups, and that will reduce the cost of the marketing of the customer relationship management. And maybe you can select further you just those that have high value and you have certain package for them. Those that have medium value, you may have different package, different treatments for the customers. This is the that means business will be more individualized. It will not be like the one rule them all, something like that. Now it become more like segment based, which is actually a way to go right now for business to survive, to be profitable. Otherwise, they will not. They will. I know that I also want to have like cheap, always like a cheap offer for me. That is cost effective for individuals, but we also need to put our shoe in terms of if we were to part of the shareholder or part of the business, we want the business to flourish, and it has to have an intelligent way to dealing with its business rather than just having a rule and let the rule works. The rule based is the old thing, right? Data driven is more like the actual thing right now. So that means you will be able to identify potential churner, and then the business will be able to identify potential churner and then intervene with that by using some type of retention campaigns. Yeah, another logo here. So sometimes you might want to upsell, right? Increase the spending of a customer, like this data upsell. You need to know which product to offer and to whom. How to know that, right? Again, you need to collect the data from in the past, data like this, that this is positive offer, that this is the customer that got offer and then later purchase. Maybe this may be some of you that got offer from SMS and then you purchase it. Then this data will be collected by the input data before the offering, and then you know that this customer accept the offer. Positive natural, it means that without offering, the customer purchase, right? And negative offer, meaning that offering but not purchase. Then all these types can be used to train machine learning model to classify, to build a function that can evaluate the score of a customer, whether this customer would like to purchase product A, B, C on what probability. And then you will know that, okay, probability C is the highest. That means customer would like to, maybe are interested in product C. Right? And with this, you can use this to drive the marketing, right? To connect the user to the right offer, and then increase revenue through that upsell. Okay, and that is the outcome of this. And you can also use these are more or less supervised learning. That is, you create model based on the label that okay, this customer really did purchase or not purchase. But sometimes you might want to just study the patterns, like you want to know the recharging pattern. The telecom company want to know whether you are regularly charging your phone or just charge when you need to charge to keep it alive, or you charge your phone in irregular manner or when the money run out. Right? How to do that? There are multiple techniques to perform this. This is called pattern analysis or data segmentation. Right? You want to segment the customer, segment the data into groups. Each group would have similar patterns. There are many ways to do that, like doing clustering or doing something like this, survival analysis. Right, survival analysis allow you to identify survival curve. Right, this is advanced statistics. I think even beyond the statistics that you learn in your stat class. So if say it's just one model that gives you the survival curve, which is the pattern that you will do certain action. Okay. Hopefully, if you are studying in master degree after this and come back to this slide, it will illuminate you more, whatever. Or if you are interested in servo analysis, maybe read about them after Stat 101, the Stat course. It is very useful technique to study regression with time. Okay, now you will have the pattern related to time, and then you can do cluster to chain, like group them into group. Then you know that, okay, you got a regular group. If you got a regular group, you can find the marketing plan that how to say estimate that, okay, customer would probably recharge at this time. You can send them the offer. Maybe if they purchase more, then they will get more, right? Do the upselling at that time, because you know when to approach. This is something unrelated to this course, but usually when you do data science, you need to know something that are unrelated to this data analytics stuff. You need to know like general knowledge in business, like what is marketing. Like there is one concept in marketing. It's called 4P. If I remember correctly, it's product, price, plan, and place. Right, the 4P. Is it correct? Yeah, the 4P. Yeah, I think it's correct. Or promotion, product, price, promotion, and place. Yeah, I don't remember the whole thing. Not really, although I'm doing this market predictive analytics a lot. Never mind. So one other thing is that you need to figure out, place, promotion. Yeah, promotion, not plan. So that's price, place, promotion. I confuse it with the Minecraft whatever that my son told me, like something like plan whatever. Minecraft Island. Okay, yeah, product, price, place, promotion. Okay. What does it mean? It means what type, what price should you set, right? And what promotion should you offer on which place, right? And place that sometimes that also refer to the time as well. When should you offer? And this will give you the time that you should offer. Say, maybe 15 days apart from the last recharge, for example. Or sometimes you might want to influence the charging pattern to increase the frequency. And that can be done by carefully sending the offer maybe before the actual time, and then try to increase the frequency of that, maybe to reduce the churn probability. Or to detect that, okay, customer should come to recharge here, but he's not coming. That means something wrong happens. That means the customer may leave the company already, right? This is survival analysis. What types of data you need to use? Something like this. You need to have the data like time between recharging. You will be able to do that. Okay, this is another example. Right? I go through a lot of examples here. This is credit scoring. When you apply for loan, right, the bank will evaluate that whether you have a good credit or bad credit. Right? What are the scores of your credit? How do they do that? They would use the data before application. This data can be your debt, your income, your guarantor, the collaterals that you use, ability to pay, and whatever, a lot of things here. And before the application, then they use this data to predict whether after 1 year, whether you are still a good customer or whether you turn bad, right, become NPL. And collecting those data, they can then build a model and then make a prediction, right, and then have certain scoring to score that, and then use this model before it happens at this time to evaluate whether you have like high risk score or low risk score, right? And that allow the bank to evaluate whether they should approve your application or not. Yeah. Right. Data model can be used to create a product recommender. Product recommendation take the transaction and then create a recommendation list which can use automated distribution. Like you can think of this as Netflix. When you view Netflix, you see that there are like the movie that they recommend. How do they get that? It comes from data analytics. Analyze the data. They know that you like these types of movie, or the customer that are like you watch this movie, and then they pick those to create recommendation list, and then they distribute that to you. Okay. You can use the analytics to study customer preference and then optimize the offer based on those preferences. Like Sarola derive customer preference based on the transaction that occur. And now I would say that Shopee, Lazada also use that strategy as well. They optimize the product show on the application based on the previous transaction that you have. You can use the analytics to you can see that there you can do plenty of tasks here. You can do it. You can do sentiment analysis. Create an AI that can read text and know that this is bad, this is good. Whether customer like that, whether there is a probability a problem with the quality, for example. And to do that, you need to gather data, create a crawl the data from social network, and then build a classification system. You learn about classification system after the midterm. I would say midterm after the second evaluation, and then maybe you can use this technique to create a brand tracking. This is one of the startup company from our department. The company is named it Insight Era. Insight Era is a company that perform social analytics service. And marketing as well. So they have this type of dashboard that provide for their customer that to know that okay, the company got mentioned on different types of topics. So they perform like text analytics, AI, and then incorporating that into service here. Okay. Or you can use the analysis to perform something like predicting house price, predicting economics, so that you know how to invest. What would be the best way to get the highest gain, right? So that's it for the first lecture. Quite a lot, I would say, because for some courses on the first lecture they will just chill and then let you go, but not for me. Yeah, usually I always has the introduction of the thing that you need to learn on the course starting from the first lectures, but we got chill later on. I guess. All right, this is it. Do you have any questions that you like to ask? Please fire away. It can be about the earlier part as well, about the course, or something else related to data analytics and data model. Oh, and actually, and don't be afraid that this will be more like a theory. I can guarantee that everything that I teach in this course comes from the actual work that we work with the company. I teach it a lot. I taught a lot of companies to do data analytics, data science, and I also provided the consultant service, the development service for them, building a model, building a system that integrating with their actual systems. So a lot of discussion in this course will come from the real things. So if you have questions about the prospect of this career, you can ask. I can guarantee that this is once called a sexiest job. No, not sexiest. The sexiest job of the 21st century. Data scientist, being data scientist. But right now I would say, after you being data scientist, data engineer, AI engineer, these are jobs that would guarantee the future career path for you, for sure. And it's not just you need to just analyze or data analyst that interface with business. And it's not just analyzing data. You can incorporating and the data analytics to different aspects of future technology as well. Because in every business, in every service, you need to make them accessible to human. And the way to do that is to allow the system to be simplified into a model, and then building some type of dashboard, type of visualization to communicate that with human. Okay. Any question? Oh, and the exams will be conducted through class marker. I don't know if you have been familiar with that or not. I have been using that in the COVID era here since the 2019, I guess. It's worked quite fine. I will use that for the exam. Oh yeah, and this is a task that I will give you that you need to do. First, you need to install R and RStudio. First task, installing R. Here, r-project.org. Just search R language. It will bring you here. And download, I don't know what operating system you use, whether you use Linux, Windows, Mac, work fine. Download R, right, first, and install on your computer. Then download the RStudio. The RStudio would provide interface, IDE, the free version though. Use the free version, okay? The open source version here, RStudio, and download it into your computer, because this will allow you to interactively use R, and you can see that RStudio is used by, say, a high level consultant company or NASA and lots of academic. There are lots of packages, library available to use in R that allow you to do different stuff, right? Okay, install R and RStudio, and then because next time we will learn about R programming, right? So these are the things that you need to do. Think about it as your first assignment. Install R and RStudio on your computer and use it next time. That's the first one. The second one, the second thing that I like you to do is to form a team. Because there will be a project, you need to form a team of 5, and then you need to pick a data set. How do you get the data set? You can get the data set from website like Kaggle. Kaggle.com. Something like this. Did I share it here? No. Oh yeah, because you need to do the project here, right? A team of 5, and then do the visualization and modeling. Okay, you can get the data set from a website like Kaggle here, which you can download the data set. Try to pick the one that is interesting and challenging, right? The one that is not challenging is kind of boring. Maybe something like Bitcoin. What do you want to do? Historical data, 105 megabyte. Well, but this is the price data, not fun. I think it's the blockchain data, historical data here, but it's in BigQuery. You need to learn database and to use this, so it'll be a little bit difficult, but you can access like transaction data. And for this one, you know that okay, this is the transaction size, and you know the timestamp and what is not input output transaction. No, not this. The other one, I guess. This one. Then, yeah. This one is a little bit challenging because you need to use the BigQuery to query the data, but you can have this transaction data on Ethereum to obtain the address, I guess, address, true and from address here, address of sender, address of receiver, and the amount. This is the amount of gas, the amount of the value transfer, right? Something like that. And yeah, you now can analyze blockchain if you want, or maybe you might be interested in some other thing like COVID-19 to be in the trend. Coronavirus dataset. Right, this is coronavirus dataset. And different way to do that. What you should not do is to copy the notebook directly from the site and then use it as your own. Doing so, the penalty is F. Okay. On plagiarism results in F. So be careful. Project is only 20%. Copying from the web, make it 0 for every part. Like make your effort become worthless in every part of that. So don't do that, right? Because there's this on every of these you can get the code, you can get the existing notebook. You can use that example to look at how they did whatever, but do not copy from them because you need to explain what you do. I know that easy. You can look at Stack Overflow, but this is your own study, right? You need to understand data in order to be able to use them. Okay, do not copy and plagiarize that. Okay, what else? Yeah, you can search for the data set that you like to study, and then investment, music, or even games, right? Yeah, ROV, right? Not Game of Thrones. I know ROV. Data set. What is the full name of ROV? I don't remember the game session. Let me search for Hearthstone instead. Yeah, something like Hearthstone transaction. Nah, this is history. You want data set, then here data set you can use. But it's League of Legends, Arena of Valor. I don't know if they will have the data set here. Esport earning. Yeah, it might be interesting. It's not the game's data, but it's like esport earning data. If you want to use that, feel free to do so. So what you need to do is to submit the proposal for me before this date. Okay, I will create a submission link through the LEB2. All of the work here, you need to submit them to the LEB2. We use LEB2 to be like the place that you can submit your lab and also proposal and project report. Right? So that's about it for today. Did I forgot to change? Yeah, I did. Forgot to change it here. Okay, because you have to create visualization, create model, form a team, choose a set, and talk about that in the team on what you want to do. Because you still haven't learned about how to create machine learning model yet. Maybe you have to wait for that later on. But if you already know what you want to do, like prediction, then feel free to specify that in the proposal. Because what you are going to learn first will be how to create visualization, how to use R, right? Any question that you would like to ask about this course? Okay, yeah. Now you have two tasks: install R&R Studio, and form a team, and talk to your team. What types of things that you want to do? Surfing around, researching first what you want to do. For now, generally the idea, because it's you will not have enough time if you there are many students that kind of do the project just like the last 2 years. This is not enough, right? There are a lot of work to be done here. So I would suggest starting doing that since now, right? Starting doing that now. That will help a lot, right? Okay, no question? If there's no questions, let's call it a day. And I will process the video, the video, and then upload to YouTube, and then post it into our group later on. Then you can view on that. Okay. Right. So for now, let's have a nice day for the rest of the day, and see you again next Monday. Bye.